Okay, so basically in this video what I want to do is that I have a Blue Yeti, basically one of these microphones that that essentially has a problem. Okay, so now before I tell you about the problem, let me show you basically what I have opened from this thing. So essentially when this thing is closed, it's something like this, and then there is basically, let me hit something over here. There is essentially one screw over here, one screw over here, and one screw over here, which is beneath this cap, or this plastic part. And you're not supposed to, of course, drop these things. So that happens to be below this plastic part. You have to kind of pry this open, and then below that there is beneath that there is a screw. Once you open these screws over here, you can see that there is basically these types of screws, and then this basically, but then essentially before you open this, there is all of these knobs. That one of them is volume, that goes over here, for example. One of them is the mute button that goes over here onto the board, and one of them is the on the other side you have the pattern button, and you have the gain button, which is essentially these two things, that you would find on this side of the microphone, and then they will be going into, so this side over here, this is the pattern, and this is the gain, right? So this is a selector switch, and this is a potentiometer, and for whatever reason this potentiometer has 1, 2, 3, 4, 5, 6 leads. I suppose this is a stereo type of potentiometer, if I'm not mistaken. I don't really know. But, and then on the other side, essentially you get the other board, and this board would be this way and in the microphone, and then this would be, this way, and then this would be the mute button, and this would be this potentiometer, which is again a 6-pin potentiometer that is basically related to the volume, and that controls basically the volume that the volume that controls the output basically the what do you call it, the amplitude of the signal that comes out of here, right? And this is the USB jack, which connects to the computer, which is this thing over here, right? Okay, so now once you open all of this, so essentially you open these 3 screws, and then you have to be very careful with these 4 knobs, these 2 and these 2. You have to pull them out using, for example, a pair of nose pliers, but then you have to use, for example, I used, for example, this rag over here, and suppose that, for example, this thing is inside. I put a piece of rag over here, and for example, with the nose pliers, basically I pulled this out. It's not that hard, you can pull that out without any problems. Okay, now that is basically this part. And then the microphone, that basically this part comes out, and then these 2 boards are mounted on here, and on the other side like this, right? Something like this. Essentially, you have to, of course, do it properly, but then essentially they are like something like this. Okay. Now the problem that I have had with this microphone is that this basically, there is sometimes a lot of noise in this microphone, and and I have been speaking into this microphone for a long time, and again for a very long time, meaning that I bought this microphone about 5 years ago, and in these 5 years I have been speaking and speaking and speaking the whole time it's been used and used and used. I've been actually driven this microphone really hard. And now it's got basically, now there is essentially, it works. I mean, the computer recognizes the USB port and everything. There is no problem, but the problem is that it has, sometimes there is noise in the audio. And this is essentially a very bad type of problem which you cannot troubleshoot, meaning that there is that the problem could be essentially anything, right? This is not something, for example, if it was something like, for example, this jack, and if this jack, I've seen on the internet that this jack is broken and people try to repair it or something like that. So this is a problem that, you know what it is, you can, I don't know, you can do whatever it is that you want to do and repair the jack. But then this sort of noise could be from anything. And I have no schematic of this thing. And the only thing that, since the microphone is working properly, I mean, the logic board and everything is working properly, and there is no mechanical damage or anything. The only thing that could be the problem, and then of course these switches are all right, these potentiometers, as far as I can tell, there is no dirt or dust in them or anything like that. Although that could potentially be a problem, and for that I'm going to, now this part over here, this is the volume. This is not that important. This potentiometer is the volume which controls this thing over here. But essentially this controls the gain. But again, that could not be the problem for the noise, essentially. But anyway, what I'm going to do is that I'm going to essentially clean these. Okay? I mean, it's easy enough to clean these, so I'm going to use, this is contact spray, in German, of course. So we can clean these out. Also the potentiometer, which is of course not really necessary, but well, it's not. It doesn't hurt to clean these. So, and you need to carefully rotate them a couple of times so that if there is any dust or dirt in them comes out, then you need essentially you need an air compressor. But I don't have that over here, so what I'm going to do is so that's good enough. Okay. Now what I'm going to do, so what I suspect is that these electrolytic capacitors, they must be the source of the cause of this problem. There is one of them over here, and there is one of them, and there is actually 4 of them on this board. Now the problem with the problem that I have right now is that, first of all, I don't really know. I mean, I cannot really see what's written on these capacitors. They are very small. I have no microscope, and I'm using a magnifying glass. You can't really see it. I mean, I can't really see it. My eyes are not that good anymore. And, well, most probably the value of these capacitors are not that important. I mean, these are most probably in some power supply circuit or something like that. They are, and so these are not that, I mean, the value is not that critical. And what I can tell from, basically, I have basically looked at them through the magnifying glass, and what I can see right now is some, well, to be frank with you, I can see a couple of things, but, well, but what I can tell essentially is that all of them have the exact same writing on them, meaning that they must be the exact same capacitors here. And this one over here is, what I can see is there is a 107A on it, but I don't know what this coding actually means. So what I'm going to do is that I'm going to essentially replace all of these capacitors with new capacitors. And the way that I'm going to know what these are, I'm going to test these using a multimeter, something, for example, something like this, or something like this multimeter up here, for example, something like this, or something like, for example, this multimeter here. Or you could use also, for example, some multimeter like that, but this multimeter does have a capacitor meter as well, but I don't really trust it. It's way off. I'll show you the values and I mean the reading and this thing as we go along. Okay. So now what I'm going to do is that first we have to open these things, or actually take them out of the board. Now in order to do that, this one is easy. You essentially need a soldering station, something like this, some soldering station like this. I'll show you what I mean by that. So essentially some soldering station like this, and then it basically blows hot air, and I think I'm going to need a pair of tweezers, for example, to take this one, and you need to be careful not to damage anything, because if I want to, for example, take this one out, there is a whole bunch of capacitors and all other things all around this capacitor. So if you're not careful, basically you might actually knock them out of their place. So you need to be careful with that. But essentially, like that. Oops. And you need to be careful not to burn yourself. Okay. So that's the capacitor out. So now what I'm going to, here is the capacitor. Here is the capacitor. So now what I'm going to do is just simply test this capacitor and see what sort of value it has. So I set this to capacitor meter, which is this thing over here. And if I, okay, oops. Now there's there's a problem right now. Okay, let me see. Okay, so one thing that I didn't pay attention to is that, of course, these capacitors, believe it or not, I had a marker over here, somewhere over here. Hopefully we can find it. Where's my marker? Okay, so essentially these capacitors, of course, they have a polarity, right? Now I was lucky that basically when I removed this capacitor, it got, basically I mean, this just happened by accident that I got it in such a way that then I could put it back in, and now I know basically that the original direction of the capacitor on the board. But you have to mark essentially how you got the capacitor out. So what I'm going to do is that, for example, first of all, I don't really know where is the positive and where is the negative on this capacitor. So I'm going to mark this side of this capacitor and this side of the board, and that way I know how to put it back in, right? Well, I used to repair electronics a while ago, and back then there was still no surface mount devices. Now everything is surface mount, and I'm not that, and I don't like these surface mount devices that much, but well, they are around. So now let me check this capacitor. Let's see. So as you can see, it is 104 microfarads, 104.5 microfarads. So I'll take it as 100 microfarads, for example, right? Okay, so now I was actually playing with, as you saw, basically this multimeter over here is showing me essentially, let me get rid of this light over here. This multimeter over here is showing us 104. Which is not the right reading. This is 103.8 microfarads, okay? Now, there is also this multimeter over here, and this one, if you set it to, this is an LCR meter. It seems that this is also working properly, although I noticed that it had a problem with resistors, but it seems that with capacitors it has no problems. So if you that one also is showing 104.1 microfarad. Now this capacitor meter here, this is a little bit, this seems to be having a little bit of a problem. This is essentially an old one, but let's see if that, you see over here is jumping 10, 12, 19 picofarad, 18 picofarad. That is wrong. That reading is wrong. Let's see if I can. I think now I have 79. No, that is wrong. that has a problem. You don't have to listen to that one. But this capacitor is essentially 105 microfarad, but for whatever reason, and these capacitors, essentially there is a mark on one side that says that basically it is the positive pole of the positive terminal of the capacitor. And this, for whatever reason, has been, you can't see it properly. So what I'm going to do to make sure that basically this side of the capacitor is really positive, so what I'm going to do is that I'm going to charge the capacitor to some voltage, like for example, I don't know, 15 volts or 10 volts. Okay, 10 volts or so. And this is negative and this is positive. I'm going to now charge the capacitor to 10 volts, and I suspect that here's the capacitor, and I suspect that this is, and as you can see, you can read that I have 10 volts, that I have, this is negative and this is positive over here, and this is 10.261 volts, right? And if I change the polarity here, you can see that you have negative 10.261 volts. Okay, so I'm going to charge this capacitor to approximately 10 volts. Let's see if, but before we do that, let's actually make a reading over there on the capacitor, if it contains any charge. So right now I'm connecting the voltmeter to basically to the two poles of the capacitor, and you can see that it seems that it has no charge on it. No charge on it. Absolutely no charge. Okay. Now, if I charge the capacitor by connecting the power supply to the capacitor, so this is basically my power supply set to 10 volts. And I'm going to connect this to negative and positive. And you have to be careful about because sometimes you could actually burn your capacitor. Actually, I'm not very much experienced with these SMD devices, so I'm going to set the current to, for example, something like 100 milliamp or so, or 50 milliamp or so. This is 37 milliamp, 50 milliamp, for example. 50 milliamp, right? So now that the current cannot get over 50 milliamps, so that means that then if I connect the poles not properly, then there is no problem. I mean, I cannot explode anything or anything like that. So I think that the capacitor is charged, hopefully. And now if we basically measure the voltage here, I have no voltage here. Zero 0.01 volts. .6 volts. Doesn't make any sense. So let me do it again. Charge the capacitor. Let me discharge the capacitor. And you want to discharge it, you can just simply short circuit the capacitor and you can discharge it. And then again I will charge it too, and I'm assuming that this is positive. So connecting positive here and negative here. And even if it's drawing any current, that my amp meter and the power supply is not showing anything. And now if I, and again this is positive, so if I measure the voltage here, that should tell me about exactly 10 volts. You see over here, now if I measure the voltage, it tells me that the voltage is exactly 9.9 volts, right? If I change the basically the you see over here, if I measure the voltage this way, now I'm reading 9.7 volts, right? And if I change the polarity, or basically change the way that I connect the multimeter to the capacitor, I'm getting negative 9.6 volts, which means that this pole over here is the positive, right? And this positive pole was connected when I opened this, is connected this on this side, which I have marked over here, right? So which means that this side is positive. So all that I need to do now is fire up my soldering iron and get any sort of some capacitor around 100. Oh, that's too much. Now the only thing that I have here is the only capacitor that I have, which is 100 microfarads, is 100 microfarads, 40 volts radial, well, which is, I mean, it is of course way too large, but well, then we can, I think we have enough space in here, so we get no problems actually, right? Or you can actually, what you can do, is that we can put two capacitors in parallel, because this is way too large, right? So I have basically also these little capacitors, which is 47 microfarad, 25 volts. If I put two of these in parallel, I will essentially get basically around 100 microfarad, but then again, this is much better, of course, than the other one. So I'm going to put two of these, but then before I do that, I need to make sure that so essentially when I put this back, this goes in this way, right? So this goes in this way, and then this is, I mean, the other board goes the other way around on this side, right? So something like this, and then the capacitor would be here, and these are the screws that you have to fasten these four screws and these four screws in order to put get these boards over here. And then on this side, this goes in, and so you have a whole lot of room inside this thing, and you get to no problems actually. So what I'm going to do is just simply Okay, so what you want to do to put these capacitors in parallel, what you want to do is that you want to connect the, right now if I basically charge these capacitors to basically if I measure the capacitance on these capacitors, you can see that it is basically or I can actually use the other meter as well. I can use this meter as well. It's not that bad, but and it used to work. Okay, so that's, I suppose you can read it. And now if I connect the capacitor, one of the capacitors here, you can see that it's 47 microfarad, right? The other capacitor that I have picked from that box is again 47 microfarad, okay? So this basically means that each of these capacitors is 47 microfarad, each one of these. Now if I connect these together this way, meaning that if I connect negative to negative and positive to positive this way, negative to negative this way, and positive to positive this way, and now if I measure the capacitance here, you see the reading is, as you can see up there, it's 93 microfarad, which is very close to 100, so we have no problems. So what I'm going to do is put these two capacitors in this circuit in this exact same way, and okay. So what you want to do is, so essentially this side over here is positive, this is negative. I don't know if you can see really anything here, but this side over here is positive, and this side, which is closer to the edge of the board, is negative. And I think that if you check, this must be also grounded, meaning that if you set your multimeter to, for example, to short circuit, and if I now see that this is short circuit, and you see over here, when I go, it seems that basically, well, of course this is the ground on this board, right? This thing over here, this whole basically this whole basically area over here, and even these screws and everything over here is the ground, meaning that this where you would put this screw is the ground. And when I touch it to this is the ground, but it seems that these screws are actually not connected to the ground. It's odd that it's not the case, but anyway. So this is negative. So what I'm going to do is just simply connect this to over here to. So I can put it, for example, this way in the board, or on the board. This is, and this is negative over here. So then what you want to do is No. Oops. Okay. And this is negative. And this is positive. Okay. And then okay, so there you have it, and then we need to connect the other capacitor here as well, which I'm going to put this way. Actually, I'm going to I don't want to short circuit anything, so I use a piece of these. I use a piece of these. I'll use a piece of this heat shrink tubing here. I put this over here, and this goes in here, and it's too long, I suppose. And so this goes to negative. And this goes to this goes to positive like this. Okay, so there you have your capacitors, basically 247 microfarad capacitors are connected here in parallel to get a capacitance of 100 microfarads. I don't know if you can see anything really with this camera. The camera is really not great, but well, okay. The next thing that we have here is, and of course there is a whole bunch of, let me see if you can see really, there's a whole bunch of basically capacitors over here, for example C26, C25, and these are all ceramic capacitors. And of course, I mean, it takes, I mean, these capacitors usually don't go bad, so there is usually nothing wrong with these. but the electrolytic ones, they usually have problems. Now these capacitors, we have basically we have essentially these capacitors over here as well. We have this one, this one, this one, and this one, and these have problems. I mean, I suspect so. So I'm going to mark the positive side on these, positive, 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 and positive. And then very carefully I'm going to try to open them, which is no easy job, I suppose. Okay. Let's see if you can do it actually. Let me see if I can bring you a little bit closer to. Okay, so I think now you can see a little bit better than before. Okay, so now let's see if we can open these. And we need a little bit of light here. Okay, so I've managed to open two of them, and there is one over here as well. Okay, so that's the third one, and there is a fourth one over here. Okay. You know, there's 4 of these capacitors that okay, so now let's see what sort of capacitance we have over here. Positive, 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 and this is also positive. Okay, I don't know if you can see anything really, and neither can I, but the capacitors are essentially over here, and I'm trying to measure the capacitance on them. So now if you go to let's take a look at these. Let's take a look at these capacitors here. The first one is, I think the way that so these are all positive. So that's something about 0.1 nanofarad. 10 microfarad. Okay. 10 microfarad. 10 microfarad. As I said before, these are all the same capacitors. So basically, these are all 10 microfarad capacitors. So what all that I need to do really is get 10, basically 4 of these 10 microfarad capacitors. These are reasonably small. And just put them on the board. Okay. So this is 10 microfarad 16 volts. This is 10 microfarad 16 volts. 10 microfarad 16 volts. And 10 microfarad 16 volts. Okay. And then basically what I'm going to do is just simply put them, one of them I have to put over here, and of course I need to make sure that I don't. Okay, so what I'm going to do is that just basically put them onto the board. And this is supposed to be these are all positive, so this becomes negative. Okay, so this is one of them. So that's one of them. And then you have to kind of put them back on the board so that, okay, that's one of them. And the other one is right over here. So what I'm going to do is again put this, I have to clip these, and then again this is positive, so this becomes negative. And this is positive. And of course I cannot see anything here, really. Okay. Not bad, but Well, you know, in the past things were much larger. So, and my eyes were actually younger. Okay. So now this is positive. So the other one is, so this is now basically two of the capacitors, these two. And you have one capacitor here and one capacitor here, right? So now let's do this one. Okay, so I'm going to put some solder over here. Actually, what I'm going to do is that I'm going to put the solder only on one side, because the last time that I did it, it was not the best decision. And then what I'm going to do is just simply put this thing over here, for example, something like this. And then this is positive, so this goes over here. And you have to make sure that you don't short circuit anything. Okay. And then that is this one. Okay. It's good enough. And this one is a little bit tricky because when negative goes over here, so I'm going to put this way. I'm going to connect the negative right here. Okay. And then the other one goes over there. Not sure if maybe the one. Oops, that was too much. Okay. Now what I'm going to do is very carefully. Now these are the 4 capacitors that we installed on this board. One here, one here, one here, one here, and that's about it. Now, if the problem is more advanced than this, of course, there is no way that I can sit and, I mean, for example, you can see that there is on these microphone elements, essentially on this side over here, basically on this head, there is basically, I think there is 2 or 3 elements, microphone elements in there. That's essentially the actual thing that you speak into, and then the impedance of that changes as you speak into it, and then that impedance goes into, it must be 3 elements, of course, because there is 3 wires coming out of here, right? So for example, parallel to each of these elements, there is a whole bunch of capacitors on this board. For example, you can see that there is a capacitor, for example, over here. There is one over here. There is one over here. Parallel to each of these elements, right? Or capsules, you can say. But of course, it's not possible for me to even check any of these capacitors. I mean, it would take me a lifetime to go through that, and so if the problem is more basically advanced than this, then what I will simply do is that I will forget about this whole thing and forget about the whole microphone, and then I will simply take these elements and simply basically design some sort of circuit, and then you can connect these elements to a circuit and use it again as a microphone. But then you have to build your own boards, meaning that with these boards, of course, there is no way that you can do that sort of thing anymore. But I suspect, but I'm pretty sure that this takes care of the problem properly, hopefully. So now if I put this back over here, which is not possible this way, I think this goes down here. So this is basically the knob over here, and this is the black, red, and blue. Black, red, and blue. So this is connected over here. Black, red, and blue. And this is connected over here. And this must be connected over here. And there is a couple of I don't know. There's a couple of screws, selector boards. Okay. So now I have written that this is connected. This is related to the selector board, which means that just simply fasten the screws. I do have a love-hate relationship with repairing things, because I have done a whole lot of repair in my life. When I was younger, that was essentially my job. So I have been repairing things for like 10, 12 years, 15 years. So okay. Now this board, there's a connector over here that has to be connected to these pins. So you have to put them on top of the pins and then insert the board in, and then there is again basically all of these 4 screws. And well, back then there was no SMD or surface mount, it just didn't exist. It did exist, but I mean, well, it was, I mean, as soon as the surface mount devices started coming, I got out of the repair business, so I was not affected by that really. Okay, so now this is your microphone. So essentially, the 3 wires related to the microphone are connected here. This is your selector switch. There is a potentiometer here, and on the other side you have this board as well. And then you have to put this back in here this way. Okay. This way. And then there is these 3 screws. One of them goes here. One of them goes here. And one of them goes here. And then I just have to fasten these screws. Okay, that's that. And then there is this thing over here. This whatever you want to call it, I don't know what to call it. This goes down here. I have to push it back in this way. And then there is basically this mute switch that goes in either way, this way or that way. This way. Then there is this volume button that goes in this way. Okay. Yeah, it's way too much in. When you want to usually this method usually works, but you have to be careful. Or you have to be very carefully. Okay, like that. And well, it's not really that important, of course, because you never really use this potentiometer. And the gain goes this way. and this is the pattern button or knob that goes this way. And I think it's supposed to be on this button here, and that is basically your microphone. Okay. Now what I'm going to do is that I'm going to, I mean, this video since I didn't have really any microphones here, I was using the microphone on this web camera using which I was recording this video. So now I'm going to record another video using this microphone here. So let's see how the microphone sounds like. I'll see you in the next video, and thank you. Okay, so hello and welcome back. So I connected the microphone to the system, and now this is basically the microphone. Of course, the gain is, they can basically play with the gain. The gain has to be at about 10 o'clock. So this is about 10 o'clock, somewhere over here, if I'm not mistaken. Has to be somewhere over here in the middle. And then this cardioid, basically this you see this, there's a function, there's something like a mathematical function over here, and this basically makes sure that there is one of these is stereo, I think one of them is mono, and there is this cardioid sign over here, which means that basically the microphone essentially picks up sound only from a like a sphere of radius, for example 30 centimeters all around, just around the microphone, and it kind of blocks out all the other sound that you have in your vicinity. So essentially, whenever you want to for example record something on your own, and you're recording something, you essentially set this to the card. The gain has to be not too high, somewhere around the middle. Now I don't remember exactly, but somewhere around the middle, basically it's okay. This is the mute button, and I keep speaking now, and you can see that when I push this button, it will keep blinking, and then you will not hear me anymore for just a few seconds. 1 2 3 1 2 3 1 2 3. That's the mute button, and of course you have to be careful not to push this unintentionally, otherwise you might. I usually do online courses, and sometimes I used to push this button, and then a whole lot of my videos had no audio on them, which is not really fun. Then you have to do all of your videos again. And as I mentioned before, this basically this controls this audio jack over here, and I don't really understand what is the I mean, for whatever reason you sometimes you need to listen to your own voice on a pair of headsets, so you use basically this thing over here, and this basically controls the output on this jack. So that's essentially the microphone. Now I need to basically listen to the audio on this video and see basically if this is a successful repair. Then essentially this video is going to show that. Otherwise, and of course then I'm going to install the microphone back to my system, and then keep testing it to see how it basically works. So I'll if there is any problems, I'll let you know. Otherwise, if you don't hear back from me about this microphone, that means that this has been a successful repair. So I'll see you in the next videos, and thank you.